The Corn Belt is a region of the Midwestern United States that since the 1850s has been dominated by farming and agriculture. Furthermore, Iowa is the state that not only grows the most corn in the country, but also leads all 50 states in chicken and pork production. Livestock and agriculture operations heavily depend on natural resources to achieve high productivity. As you can see on the map, Iowa is located within two major river basins, the Missouri and Upper Mississippi. Over the years, researchers have shown concerns regarding the effects of intensive agriculture on our soils and streams because when these systems are managed in non-sustainable ways, soil loss and water pollution will impact the ecosystem, causing nutrient loading downstream and reducing water oxygen level, which eventually creates dead zones because of the killing of aquatic life. When it comes to soil and water conservation, a commonly used term is watershed management, and one might ask, what does that entail? Well, watershed management describes the process of implementing land use practices and water management practices to protect and improve water quality and other natural resources within a watershed. Watershed management needs to be planned before being implemented. One example of watershed planning is using models to quantify soil loss across different locations and time scales. The Daily Erosion Project is a soil loss model that generates daily estimates of soil erosion and water runoff at the HUC 12 watershed level, that is, areas of 90 square kilometers or 35 square miles. The inputs used to run this model include the Water Erosion Prediction Project, also known as the WEP model, soil data from the U.S. Geological Survey, topography from satellite images, and land management databases from the Agricultural Conservation Planning Framework, known as ACPF. As for meteorological data, we have precipitation, temperature, wind, and solar radiation. So this is a very robust model. One important step to validate models is to use field data where the conditions implemented in the model are similar to those from the field. In this project, we use field data from the science-based trials of row crops integrated with prairie strips, a conservation practice that has shown many benefits for nutrient retention, water quality, air quality, and wildlife and pollinator habitat. In summary, my work compares model versus measured data collected at the strip's watershed, and we will run statistical analysis methods to test the model's efficiency. Overall, the impact of this research entails providing watershed planning guidance by informing farmers and conservationists and helping them make decisions when considering conservation practices most appropriate for their land.